Well, Drake, before we continue, maybe it would be a good idea to lay out just what the anthropic principle is, since it's come up a couple of times. I don't think we've defined it, and there are a few different ways that it's been formulated.
Yes. So one of the problems is it hasn't been consistently defined across different definitions, and the same names are used. So I think the basic definition, right, of the weak anthropic principle is that we shouldn't be surprised to find ourselves in a universe that can host us. At some level, this is akin to the argument about, why we are suited to life on Earth. It is that, we should not be surprised that we exist in this universe and are made of molecules, especially made of lots of carbon, because we live in a universe which is rich with carbon and all the other things stars can burn. So that kind of statement is almost like the boring notion of what the anthropic principle is. And in fact, that's when many people, they think that's as far as it goes. And then they say, right, that's the end of the discussion. It's a circular argument in the sense that we shouldn't expect to find ourselves in a universe where we can't exist. But the more rigid definition, when we start to get into things, is this question of the mix of the actual physical laws that we have, and the notion that if our universe had been born slightly differently, then we would be in a universe that could not host life in any form. And so the question is, and which is, it's tied to this, the fine-tuning principle, is what is there something about our universe that makes it special in terms of the physical laws, such that we are here now asking the question about the state of the universe? And so we have that question about why this mix of the laws of physics? And as we mentioned a moment ago, to many physicists, that's not a physics question, right? The physics is that here's a universe, work out how everything works in here based upon those laws. But what we want to do is go deeper and ask why this mix of physical laws that we have. And it's kind of funny when we give talks on this to physicists. Sometimes they say, well, again, it's not a question where we want to tread, but others get really involved in and thinking about how the universe would be different. And we can end up with big, long discussions about all kinds of aspects of the universe, which would change if we change the laws of physics, right? So I said, what you end up with doing is finding it's very easy to wipe out the complexity in this universe by adjusting the laws of physics. So that's where it sort of boils down to is why does it look like this universe is special? And it's special, again, in that question of complexity, not necessarily in being a universe for us, right? It's the complexity that we have in the universe that's important.
Just to make sure that I'm on the same page, I'd like to try to rehash the two of them and put them in my own words and see if I'm right. So the weak anthropic principle is the not very surprising, maybe borderline tautologous assertion that the universe has to be the way it is for us to observe it. Otherwise, we wouldn't be here. I mean, if there weren't carbon, we wouldn't be here. But then the strong anthropic principle, the why question comes in, and it says, or we're asking, how is it that it could be this specific? Why is everything so perfectly fine-tuned? And that demands a much deeper sort of explanation, apparently.
Yes, well, but again, it depends who you talk to, right?
Yes,
I mean,
yes.
I said if you want to start an argument with physicists in the pub, you bring up things like the anthropic principle, right? But if you think about it, then there's only a few sort of possibilities on the table, right? I mean, if in reality, it has to be something to do with the mechanism that brought this universe into being. So if you think about it, if our universe is a one-off event, then something was special in the initial conditions of the universe to ensure that we had that ability to form the complexity that we have around us. So that is one way of thinking about it. It's just that, somewhere in the initial conditions of the universe are written, right, and this universe will form complexity. But then you just push the problem somewhere else, right? Why these initial conditions? Now, there are some physicists, of course, who think that these numbers that we have in our theories, these fundamental constants, that they're not truly free numbers, right? They're not free values. And that maybe if we think really, really hard, we will come up with a mathematical expression that involves, pi and E and the golden ratio or whatever to give us the mass of the electron compared to the mass of the proton or something like that. So that there is no freedom in the choice of the physics that we have in the universe, that they are written ultimately into the mathematics of the universe. But you're just then left asking the question, well, why this combination of mathematics? Because, of course, in terms of the library of all potential mathematics, physics only uses a small part of it. The mathematician's library is much, much bigger than the maths that we use to describe the universe. Why did we take this book off the shelf for this universe and not that one, which would have given us a very different kind of universe? So what we're left with is some other mechanism for writing those initial conditions. And of course, this is where the arguments get a little bit aggressive. Is aggressive the right word? Yeah, well, it's hard to say anymore. On the internet, everybody shouts at everybody else. But of course, on one side, you get the theological aspect, where people saying that, of course, the initial conditions for our universe are special because the universe was, at some level, made for us, right? It was created for us by some divine being, etc. But if you think about the potential physical solutions, then there has to be something about the way either our universe, I said, was special in a one-off event that for some reason we don't understand the initial conditions were written the way they are, or we have a mechanism whereby the universe is just one of many universes, and we run into the idea of the multiverse, that there is this process, a universe generating process going on, where universes are spat out through some mechanism that we really don't have a handle on. But each universe, as it's created, there's effectively a roll of the cosmic dice somewhere, right? Physics is chosen at random, and each universe gets its own laws of physics, and ours is somewhere in the mix. Ours was the one that, roll snake eyes. Is snake eyes good or bad? I can never remember. But, got that roll. We got the right combination of the laws of physics. So here's our universe with a bubble of life in it. But out there, then, there are uncountable numbers of other universes which are dead and sterile. And so some people sort of see this picture as being exceedingly wasteful, right? That you have to produce 10 to the 2,000 dead universes for our one universe with the right combination of physics in there for there being life. So yeah, it leads to lots of arguments about why would the overall process be so inefficient? Why would we just be producing dead universes over and over again? And then you run into things like Lee Smolin's idea that in fact it's an evolution, it's more of an evolutionary process where universes with life beget universes with life kind of thing through the formation of black holes. So people try and get around that, but yeah, it's one of those questions that it's not obvious exactly where the answer lies.